All right, so now we can get into how to draw Lewis structures. And eventually when we get into BSCPR, we'll get into the 3D visualization of these molecules. So Lewis structures generally obey octet rules, except for hydrogen and helium. They want 2 electrons, right, to be like helium, which is the noble gas configuration of helium, right, 1s2. And so we have terminologies here. We have what are called lone pairs that are not being shared. They're just on one atom. So all these ones in blue are lone pairs. They're just on their respective chlorine atoms. And we have these pink pairs, which we call a bonding pair. And usually we draw that as a line. So that would mean that these 2 electrons are being shared by both these chlorine atoms. This is a favorable situation. This is how chlorine exists at room temperature and pressure, is as a diatomic molecule, because in this situation, each chlorine has 8 electrons effectively, right? By sharing, they had 7 electrons to start each atom, but they share a pair, and so they each have 8, which satisfies the noble gas configuration. So here are some steps to follow when drawing Lewis structures. First, you're going to count the total number of valence electrons in the molecule. Then you're going to write a skeletal structure, which means arranging atoms around the center atom. And the least electronegative atom is usually going to be the center atom, unless it's hydrogen. Hydrogen is always an end atom. And this is because hydrogen follows the Duet rule. It only has 2 electrons. And so because helium is the nearest noble gas configuration of hydrogen, so it can't really bond with multiple things under most circumstances. Then the third step is we're going to use a pair of electrons in drawing a line to form bonds between the atoms. And whatever remaining electrons have, we're going to complete the octet rule for the outer atoms, and the duet rule for hydrogen, and then complete the octets of the inner atoms. And if we run out of electrons to satisfy the octet rule, we're going to form a double or triple bond as needed. Okay, so we can go ahead and practice with these 6 examples. So first step was to figure out the number of valence electrons. So number of valence electrons here for hydrogen fluoride is, well, there's 1 valence electron for hydrogen, it's in group 1, and fluorine is a halogen, so that's 7, so it's 8 valence electrons. So that's good, that's step 1. Step 2 is write a skeletal structure arranging atoms around the center atom. Well, we only have 2 atoms here, so nothing's really in the center. So we're just going to put H and F and connect them by a line. We'll start out by drawing a single bond, and then later, if we need to, we'll have double or triple bonds. And now we think about the duet rule for hydrogen. Hydrogen wants 2 electrons. It already has 2 electrons. There's 2 electrons in this line that I drew here. And then, so we've used up 2 electrons. And so what do we have left? We have 6 electrons left. And where are those going to go? Well, hydrogen's already happy with 2. So those are going to go on fluorine. And 2, 4, 6. And we want fluorine in the end to have 8. 2, 4, 6, 8. So that's good. So fluorine satisfies the octet rule. Hydrogen satisfies the duet rule. And total number of valence electrons is 8. Again, 2, 4, 6, 8 drawn on the board. Good. Let's do our next one. Nitrogen. Similar thing here. We're going to start off with number of valence electrons. Nitrogen is a finctogen. It's in the 5th group there, so it has 5 electrons. 5 plus 5, there's 2 of them. It's 10 valence electrons. There's no central atom again because there's only 2 atoms here. So we'll start out just pointing by N connected by a line. Now, what are we going to do? Well, we put down 2 electrons on the board. That means we have 8 electrons left. So you're just going to split them evenly. That's the best way to do, usually pairing them up. So we have 8 electrons left. So I'm going to put 2 there, 2 there. That means I have 4 more left, 2 more, 2 more. So let's count total. 2, 4, 6, 8, 10. Good, we satisfied the total number of valence electrons. Problem is, though, each nitrogen here only has 6 valence electrons. Let's count. 2, 4, 6, not satisfying the octet rule. They want 8. This nitrogen, same problem. 2, 4, 6. So we've run out of valence electrons. And when this happens, this is when you start making double and single bonds. So we're going to take these 2 electrons, it doesn't matter which one you choose, and we're going to put them in the double into another bond. And so then we're going to have something like this. I remove these lone pair, and I'm going to have it like that, right? And now let's count. Still, we have 2, 4, 6, 8, 10. We just moved electrons into the bond to make them share. And this nitrogen is now happy, 2, 4, 6, 8, octet rule satisfied. But this nitrogen still isn't, 2, 4, 6. So what do? Well, we're going to make a triple bond. So we're going to move another pair of electrons from the other nitrogen in, and now we're going to have a triple bond, and all we have left are one lone pair on each nitrogen. Still, we only have 10 electrons, 2, 4, 6, 8, 10. That's good. Satisfy that. And what about for each nitrogen? 2, 4, 6, 8, octet rule satisfied. 2, 4, 6, 8, lone pair, octet rule satisfied. So we're done. All right, here's one. Now this is the carbonate anion. Here we have a central atom for the first time. And we have multiple things we have to consider when we're calculating the number of valence electrons. Carbon is in group 4, 4 electrons. Oxygen's a chalcos in group 6. And how many of them are there? There are 3, so we're going to times that by 3. And now we have a 2 minus charge, so that means 2 additional electrons, right? So we have to add 2. So it becomes 4 plus 2 is 6. 6 times 3 is 18, so it's 6 plus 18 is 24. Least electronegative atom in this is going to be the center atom. That's carbon. Carbon's to the left of oxygen on the periodic table. So we're going to draw a skeletal structure with carbon in the center, okay? And now we're going to think about how many electrons do we have left. Well, we put on the board 3 lines, so that's worth 2, 4, 6 electrons. So we have 18 electrons left that we have to write down, right? And so the best way, again, is just to put these try to put them, space them out as evenly as possible. So I'm going to put 2, 4, 6, 8, 10, 12, and now 14, 16, and 18. So let's see total here. We have 2, 4, 6, 8. And you can see this oxygen looks the same as this oxygen, right? 2, 4, 6, 8, and same with this. They all look the same. So we have 24 electrons. So this is good. And are our oxygens happy? Yes, 2, 4, 6, 8. And all the oxygens are the same. So they all follow the octet rule. But we have a problem. The problem is we ran out of electrons. We have 24. 24 is accounted for. But carbon only has 2, 4, 6. We need the octet rule. So what do? We bring down one of these lone pairs from one of the oxygens. Which oxygen, you say? Well, it doesn't matter. And we'll get into resonance structures. But it doesn't really matter. There's 3 different resonance structures you can draw depending upon which oxygen you take from. But you're going to get one with a double bond, and then the other 2 are going to have single bonds. And so that's going to be your complete structure that satisfies the octet rule. 2, 4, 6, 8, 2, 4, 6, 8 for oxygen, 2, 4, 6, 8 for oxygen, and for carbon, 2, 4, 6, 8. Carbon's happy now. All of them are happy. Last thing we do is usually put a bracket since this is an ion, and just put 2 minus since this is a 2 minus, just to let people know. All right, last 3 here. Valence electrons for methane. Carbon is worth 4, hydrogen is worth 1, and we have 4 of them. So this is 8, and so this one's going to be very fast. We're just going to connect all these. Carbon goes in the center because hydrogen can never be in the center. It always has to be a terminal atom. And we have 2, 4, 6, 8. Done. Hydrogen has the Duet rule. All of our electrons are on the board. And hydrogens have just 2 across here for the one line. And carbon has the octet rule, 2, 4, 6, 8. Carbon dioxide. Carbon's going to be in the center again. It's less electronegative than oxygen. Carbon's with 4 electrons. Valence electrons for oxygen is 6. So 4 plus 6 times 12 is 16 valence electrons. And we're going to put it down here. We have 4 electrons on the board right here, 2, 4. And at this point, you could see that we have a problem, right? We're going to have multiple bonds being formed here because we need an octet rule for oxygen, right? For carbon. So let's just go ahead and do that. 2, 4, 6, 8. Carbon now is happy. And now oxygen is not going to be happy. And so let's satisfy the octet rule and see if this works out. Now every octet rule, I kind of did the octet rule first this time. Octet rule is happy, 2, 4, 6, 8 for oxygen. Carbon's happy, 2, 4, 6, 8 for that oxygen. Do we have 16 total? 2, 4, 6, 8, 10, 12, 14, 16. Yes, that's correct. Last one is this molecule here, formaldehyde. So carbon is going to be the central atom, and we're going to connect the the other atoms here. Okay, and so again, we can see here, oh, carbon is going to be missing out, and we have 6 valence electrons, 2, 4, 6. So we can't make a double bond to hydrogen. Hydrogen only wants 2. So let's make a double bond there, and let's add valence electrons to make oxygen happy. 2, 4, 6, 2, 4, 6, 8. Oxygen's happy. Okay, hydrogen is happy. Carbon, we already said, is happy. Number of valence electrons, let's check to make sure this works. Hydrogen is worth 1, but there's 2 of them. Carbon is worth 4 valence electrons, and oxygen is 6. So that's going to be, 12 valence electrons. 2, 4, 6, 8, 10, 12. There we go. We just did a lot of examples, and we'll do more in the upcoming